until now. Though we can't meet face to face because of the current coronavirus pandemic, I hope for the success of this event. Some of you may have known about APCORISE. In case you haven't, APCORISE is an annual conference held by Industrial Engineering of University of Indonesia. This year marks the third year where we'll be having 68 participants presenting their research topics related to industrial and systems engineering. APCORISE invited 2 keynote speakers who will later share with the hope of enlightening us with new insights for our scientific. Okay, now let's begin this event with Dr. Zulkarnain as the General Chair of the third APCORISE. Mr. Zul, the time is yours.
Okay. Assalamualaikum warahmatullahi wabarakatuh. Fellow scholars, participants, APCORISE 2020, on behalf of APCORISE 2020, I would like to use this opportunity to welcome you all for the participants, for the all from all over the world who will participate in our international conference, Asia Pacific Conference on Research in Industry Engineering today. This year, very unique occasion for every one of us to have conference in virtual environment because we pandemic situation. So this is new for us, for the organizer, participant, I believe. So I truly believe, hopefully, to the enjoyable conference. Nevertheless, we will have a fruitful, we will have a very productive day for today, and I use this opportunity as well to send our gratitude, thanks to all the participants that have enabled, that have their dedication, enable this conference to make this conference happen. So several notice I would like to mention, probably Mr. Andri Mubarak as the co-chair. He is the man behind the chair actually. I would like to mention our gratitude to publication led by Dr. Ramadhani Ardi and friends. Thank you very much for being, especially because this year we are in the communication. We are in with SEM for the publication. Hopefully, we will have a publication for this year. Also for the program committee from Enrico, and as well as for the treasurer, Pak Irfanu. We have also the board of reviewers that come from several institutions. Thank you very much for all the board of reviewer that has been put the hard work in reviewing the paper so that we can have altogether 68 papers accepted for this year's conference from 110 submissions. So it's quite a lot of, have a very fruitful discussion, I believe, for today's. For distinguished keynote speakers, I would like to send our gratitude to the Professor Abdul Hakim, Halim, Bandung Institute of Technology, as well as from Professor Cole from that has come along the way to share the knowledge, share the experience regarding to dance. I think that's all from me. I don't want to keep in a long conversation. So hopefully you enjoy the conference, have a fruitful discussion for today, and good luck for the conference. And much once again, welcome to APCORISE 2020. Assalamualaikum warahmatullahi.
Waalaikumsalam warahmatullahi wabarakatuh. Nine for your warm welcome. Moving right along, with Dr. Ing Amalia Suzianti as the head of Department of Industrial Universitas Indonesia to give us an opening speech. Dr. Amalia.
Okay. Assalamualaikum warahmatullahi wabarakatuh. To our honorable keynote speakers, Professor Dr. Abdul Hakim Halim and Prof. Ing Holger Cole, distinguished professors, participants, ladies. With great pleasure, we would like to welcome you to the third Asia on Research in Industrial and System Engineering, APCORISE 2020, by Department of Industrial Faculty of Engineering, Universitas Indonesia. This annual international conference is a part of our initiative to forum for researchers, engineers, and professionals to discuss and research the new technology and solutions in industrial and systems. This year, in a challenging situation where we have to face the global pandemic, and we have to hold conference in online mode unlike the previous years, I believe that APCORISE can foster the discussion on how to face the new reality, pushes digital channels and remote working to the extreme, and identifying and prioritizing a rapid response to the disruption initiatives which will help to sustain business continuity. Their schedule, and they are relentless, sowing uncertainty and disrupting everything. In these crisis conditions, resilience is a business necessity, increasingly a strategic weapon fueled by digital capabilities. Uncertain after the COVID-19 crisis has passed, but we all can be ready for it quickly and flexibly to whatever conditions arise. Closing the speech, express my deepest gratitude to the scientific and organizing committee for their commit, which make this conference a success in the first place. And of course, to all participants, I wish you a fruitful discussions and enlightened conference in APCORISE. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam wabarakatuh. Thank you, Ms. Amalia, for your opening speech. Moving on to the opening speech from the Dean of Faculty of Engineering, Universitas, Dr. Insinyur Henry. The Dean's greeting will be delivered that has been pre-recorded. So for the operator, you can start the video.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning. Professor Dr. Ing Holger Kohl, Professor Dr. Abdul Hakim Halim, distinguished professors, participants, ladies and gentlemen. I am delighted and honored to have this opportunity to welcome you to this annual international conference, the third Asia Pacific Conference on Research in Industrial and System Engineering, APCORISE, which is hosted by the Industrial Engineering Department, Faculty of Engineering, Universitas Indonesia. Actually, this Faculty of Engineering consists of 7 departments, 14 study programs. We have undergraduate program, master degree, and PhD degree. We are one of the big faculty in this university, Universitas Indonesia, that consists of 14 faculty, 2 school, and 1 vocational program. As a part of engineering domain of knowledge, industrial and system engineering is concerned with the design, improvement in installation of integrated system of people, materials, information, equipment, and energy. Especially when we are talking about Industrial 4.0 and smart manufacturing, industrial and system engineering are needed to elaborate data-intensive application of information technology at the shop floor level and above to enable intelligent, efficient, and responsive operation. By providing such this forum for researchers, engineers, and professionals to discuss and exchange the current research and the new technology, I expect that it can foster the development of innovative solutions by integrating the role of people, process, and technology. I would like to take this opportunity to express my gratitude to all delegates and sponsors for their full support, cooperation, and contribution to the third APCORISE 2020. I also wish to express my gratitude to the organizing committee and the scientific committee for their diligence. The various sponsors are also thanked for their kind support. In closing, I realize that you are fully dedicated to the session that will follow, but I do hope you will also enjoy this online conference and gain the benefit from the presentation and discussions. Once again, welcome to the third APCORISE 2020. Thank you. Billahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Right at the end of the video indicates that we can move to the next. We will now announce the best paper announcement. All of these 68 papers collected have been assessed by the Honorable Conference Board members that made it into this conference has already possessed its own scientific and astounding insights. However, there's one about the most, and thus the board of APCORISE 2020 to present the Best Paper Award to Marmelia Pedewi, Andri De Setiawan, and Yusuf with the title of the paper, Developing a Sustainable Financing Geothermal Projects, a Conceptual Framework. Congrats to the awardee for the award. May this award be a milestone and diverse. Now, moving right along to the next agenda, introduce the moderator who will lead the keynote speech this morning. Let's welcome Mr. Yuri M. Zaglur. The stage and time are yours, Mr. Yuri.
Assalamualaikum warahmatullahi wabarakatuh. Moderator, I want to read some explanation for preparing for Prof. Halim to deliver his speech. Ladies and gentlemen, welcome to Keynote speech, me, and also Mr. Komarudin as your. Before starting the speech session, read the rules in this session. 1. The keynote speech session will for 55 minutes, including 45 minutes for giving speech and 10 minutes question and answer, where the session will be guided by me, the moderator. During keynote speech session, the slides containing the material will be shared to the screen by the operator. All participants will be mute during this. All participants cannot see on this webinar, but keynote speaker can see it through the Zoom application. People who want to ask question can press hand button on the Zoom application after speech session is finished in 45 minutes. Moderators will choose 3 participants, and participants chosen to ask their question by typing them in the question and answer on the Zoom application. Incoming question directly, so directly keynote speaker, yeah. So one by one, right? Okay. Hopefully everyone has understood the technicalities of seminar. Now I will introduce the keynote speaker session, Professor Dr. Abdul Hakim Halim, briefly. Professor Halim is Department of Industrial Engineering, Faculty of Industrial Technology, of Technology. He received his PhD in engineering from University of Osaka Prefecture, Japan, and BS and MSc in Industrial Engineering from ITB. He is member of Manufacturing System Research Group. At his research interests including production planning and control, system design, manufacturing strategy. Research outcome on production scheduling in Journal of Production Research, European Journal of Operation Research, International Journal of Production Economics, Production Planning and international journals, as well as in many international national conferences. He also as one of the guests for Computer and Industrial Engineering Journal, and now of Asia Pacific Industrial Engineering and Management Society, and a fellow of APM's and IAOM, Industrial Engineering and Operation Management from 2009 to 10. Sorry, the last one, from 2000 to 2017, he has the head of coordination for the private university in the West Java and Banten provinces of research, technology, and higher education, supervising 450 private universities. Well, Prof. Hakim. In this session, he will his paper entitled Redefining the Relevance of Industry Towards Mass Customization. So I invite Prof. Halim or Hakim Halim for his speech.
Thank you very much, Professor Yuri, for introduction. Good morning, ladies and gentlemen. Happy to be here with you all as we, while maintaining social distance. My presentation, let me share PowerPoint. Okay, my name is Abdul from Bandung Institute of Technology, Bandung, Indonesia. I'm going to deliver my presentation titled Redefining the Relevance of Industrial and Systems Engineering Toward Mass Customization. The outline of my presentation: first, mass customization, and second, value creation, product system, service system, and the third, monitoring, and fourth, operation excellence, and the fifth is industrial and system. And the relationship among the topic is that mission, value creation, and operation excellence will go down to spring, and the first four topic will change the orientation of industrial engineering. The challenge from the current that we are facing now and we will be facing in the future. First, the product is increasingly demanded and not common but customized. This means that a manufacturing company practicing this production strategy will take technical difficulty and inefficiency. If the company produces product variety and small volumes. Second, the customer expects to receive the personalized product in a required level of quality, shorter time, and with lower price. This that the company should make manufacturing lead time shorter and products nearly the same as the cost in mass production environment. Accordingly, the manufacturing company should adopt the new paradigm and advance production and supporting technology as well as be operated excellently. The solution where customized products were demanded happened in the era of craft production. At the time, customers got the product but at high cost. The craft production paradigm then moved to the paradigm of mass production where the cost is low but with very variety of product. Now to another paradigm as market demand customized product with low price. To deal with the current market successfully, the manufacturing company should use with mass customization strategy based on value creation and with a smart manufacturing systems. Ladies and gentlemen, power and system engineering as is one of the discipline dealing with manufacturing system should change the orientation process from mass production to mass customization. And the new industrial and systems engineering curriculum should have knowledge and skill of product and process innovation, as well as knowledge and practices of advanced product technologies, including artificial intelligence, big data, internet, and cloud computing. Highest worldwide in 1979 introduced product process matrix. Process life cycle start with job shop, a highly flexible but not efficient process, toward a continuous flow, a highly inflexible process. Meanwhile, product life cycle with large variety of product towards standardized product. The development of process and product life cycles have not stopped yet. Now we have a stage of process of life cycle called smart and mass customization product. We have already production system introduced in the theory and practical world. First, job shop with the following character: low quantity, individual product, flexible. This is the so-called one-of-a-kind customization. A company create a product exactly the customer requests. Will bring to high cost, as the company will always start the design product, and when it comes to the production, the company should always set up systems. Second, flow shop. The character is high quantity, standardized product, and this environment is called mass production based economies of scale that brings to low cost production system, low cost, the total of variable cost and the average per product will be low. Third, batch production. The position of batch production is somewhat between job shop in variety of product and in cost. We call this mass production. However, batch doesn't focus on end user customized product, but on the trade-off between the number of setups and inventory. The next. Let me show you the position of the respective productions in a picture. So we can see that there's a job shop and flow shop. Job shop with the product variety V1 and CE1, and then flow shop in the next extreme, in the V2 and E2, and batch production is between job shop and flow shop. And we have paradigm and new strategy, smart manufacturing and mass customization with higher variety and higher efficiency of product. Thanks. What I mean with strategy to response is a production strategy. So this is the production strategy in response to demand. We can divide the strategy to respond customer into categories. First, engineer to order. Product requested by customer have not been produced before. When a customer is an order, the company develop the design as requested, which can involve both time and expense. Receive customer approval of the design, and then orders the required materials. When the materials have been at the shop floor, the company fabricate the component, assembles into the product and then deliver the finished product. Second, make the company produce a specific product requested by a customer, providing with the product design. The processing activities are to each individual customer order. Next. Assemble to order, the company has stock in assemblies or modules in inventory. When a customer order, a company soon assembles the modules into the requested product and deliver that. And the last, make to stock the company standardized product and stock the finished product in inventory for engagement to customer. Ladies and gentlemen, now we have new manufacturing system called smart manufacturing with a new strategy to respond to mass customization. We will discuss this topic of customization in more detail later. Let's have a following metric showing the relationship of production system and response to customer. So the row show production system and manufacturing, and the column show the response to customer. And also we show of each production system of each effect and cost. So we can see that either applicable or inappropriate. And we can see that job shop is customized, and smart manufacturing with mass customization also nice but low cost. Next. So we have already discussed that Microsoft deal with customization. It would the customer exactly get what they want. But and Microsoft with mass production, this will also put as low, but the customer may not get what they want. The mass customization takes the good aspect from make to order and make to that is customized product and low cost simultaneously. And is customization taken from make to order and mass production. Now we take mass, so the name then mass customization. Yeah, to define mass customization as developing, producing, marketing, and delivering affordable goods and services with enough customization that nearly everyone finds exactly what this is anything at any time. Next. Hakim 1995 proposed two definitions of mass customization. It's the visionary definition. This is the ability to provide your customer with anything they want, profitable anytime they want it, everywhere they want it, and they want it. And the second definition is called the definition. The use of flexible processes and organizations to produce varied and often individually customized products and at the low cost of the standardized mass production. The product services are customized within predetermined of variety. The goal is to assert from the customer's perspective the range within which a given products or services can be meaningfully customized for their customer and then facilitate the customer's choice option from within the range. So the two definitions can be seen achieve the ideal condition that is what Hart states as the vision. And mass customization is large and diverse range of standard options offered to the customer. For example, for motorcycle, customer can choose color and size, number of cylinder, steering wheel shape, car seat size. There are a great number of combinations. So this is find that in mass customization, there are a paradox. Because usually, okay, we start this one. It's an operation of paradox, providing customers product anything at any time. So traditionally, low cost could only by producing a standardized product in mass production. And traditionally also, product could only be produced at job shop, in which the production cost. So now mass customization is to customers with customized product through low cost mass production. So it seems to me that mass customization is to resolve between cost and customization. Right? So customization is an integration of the mass production initiation principle, providing everyone with product. Exactly. Mass customization means the company is able to achieve an economies of scale, and mass customization provides individuals with customized product while taking advantage of the many benefit production, that is high productivity, low cost, security, and fast response. And the next slide can see the classification. So please, next slide. We have classified the customization to configuration oriented, parameter oriented. In the condition of configuration oriented, customer can configure selected part of product into their own solution. And in the parameterized oriented, customer change visual aspect product size. And the more of the classification can be seen in the next slide. So this the customization is divided into four: adaptive customization, cosmetic customization, and transparent customization, and collaborative customization. So service are standardized, have a few customized options, and the company offer a group standardized product. And transparent is defined by modularity. So we make many modules, and custom as co-designer simply combine different parts or parameters of of component according to their needs. And the last is collaborative customization. We conduct dialogue with the individual. So the next slide. Maybe next slide. Again, so because this is the same as before. Okay. Also, the classification of masks is similar to the previous classification. Yeah. So it's similar to administration, cosmetic customization, transparent customization. Next. Ladies and gentlemen, a manufacturing system is to create value. So actually is to create, but indeed through producing product and services requested by customer. The value of product and services in the past were a function of economies of scale. But today, product and services is based more on creativity, the innovative way to take off advantages of new materials and process. So we start by distinguishing value creation and value caption. Value creation aims at inventing the perceived benefit to the customer by producing good or service, excellent performance or quality at the lowest price. And value aims to creating economic value, measure profit, showing an added value. So value creation is directly to measure, but to be measured by profit, perceived value to the customers. We need to distinguish the next. We will start that what we mean with customer creation, value create, value capture. So we will consider that is both are the same. Actually, it is different. Okay. Usually, it offers service for free. Let's say of after this. As a service can be a value creating core for the customers. When a company intends to value the product, they need to change mindset from as a producer of their core product to a value creating part in the customer. The company should reach beyond the functional needs of the customer, integrating product and service a customized and functional system. Need to know about customer situation and behavior. So product system is an approach to integrate of customers, engineers, and economics. So actually, we can to create the value. We don't have to make a product, but we extend the function of the product, creating the value to the customers. Service system is a concept that integrates product and services in one stream development and delivery for the whole life. So product service system is an innovation strategy. She focused from designing physical product only, designing a system of product and service which are jointly capturing specific client. Product service system is an integration of product and services focused to satisfy specific demand of customer. So we also a company maybe start from pure product. And the last condition is change the be a pure services. And there is between these two extremes, named category product oriented. Product oriented services sell product to customer who own the product. So the customer own the product with some additional services. And category use oriented services. So the product are owned by company and made available to customer in different company sell function instead of product. And the third, oriented services where customer and service agree on a desired outcome without specifying the product involved. For example, pest control service of pesticides. Yeah, and from category B, for example, we don't sell the photocopy machine, but the customer when they need to copy a document. Next. So we are going to talk about smart manufacturing. First of all, I'd like to see the traditional manufacturing. In traditional manufacturing system, production, planning, forecasting. This forecasting is to determine the product and then use this result of forecasting process to be aggregate plan, and then the aggregate is aggregate to be a master production schedule, and this master will be an input, one of the input to inventory management. And then we have a plan, production plan, and activities also will be based on the bill of operation, and the standardized product will on the bill of material, and all is come from market research. In this traditional manufacturing, no communication the company and its customer, and the system separate the bill of operation, bill of material. And then we can see the smart manufacturing. So the next slide. So let's have a look at how smart manufacturing. So characteristic and mass customization. First, adopting different manufacturing processes. Smart manufacturing adopt different manufacturing process. The infrastructure for ERP also still used by smart manufacturing, and taking advantage of the web and data structure like generic bill of material and bill of operation, designing, creating integrated system, having the ability to handle uncertainty in product information without affecting lead time and cost of work, having the ability to transform and assemble to produce custom product, adopting a simplified, customized, and handling process that focus on reducing time and implementing mass production by modifying the product, process, and system appropriate. So, next slide, please. McCarthy, identify 6 fundamental processes in smart manufacturing with the mass customization strategy. First one is order picking and development and design, and third, product value. and then order fulfilling management, order fulfilling realization, and post-processing. Now we can see the next slide, the explanation by teacher. So you can see that the company managed adapt the customer to interpret the customer wish. This is taken in picking or coordination stage. Yeah. And then the next, product development design. So the company handled the design for, and then the next, product validation and manufacturing engineering, translate the design into manufacturing. And the fourth is order fulfilling management. So production management, there's production management and supply chains, and then fulfilling realization. So this is activity that may follow the competition of including playing and guiding. And this is the last, yeah. In the fifth order fulfilling realization, this is the delivery activity. In the sixth post-order process, this is after sales, claim, right? So this is the smart manufacturing identified by McCarthy. Next slide, please. So maybe we can these two slide, because this is actually the same as the position of job shop, batch production, pro shop, and how the relationship to mass customization. And we have already discussed this in the previous. So maybe we can skip to the next slide. Please, next slide, please. So we have already known that traditional manufacturing into a set of operations to convert raw material to finished product. Meanwhile, smart manufacturing is a set of manufacturing that use network data, information and communication technology for governing manufacturing operations. IC is used to make up planning and control of this. Manufacturing is the data-driven operation at all levels of system management, manufacturing external system, and shop load, all manufacturing system level to produce custom low cost. Property are not created production, but by process. It means that we try to connect with the machine. Yeah, connecting the machine to, or maybe we can say this full approach manufacturing. And in this days, smart manufacturing consider it's not a production system, but as a service center. Next, please. So I understand from the written by Mitai that smart manufacturing be defined as that the smart manufacturing has 5 characteristics: context awareness, modularity, handlability, interoperability, and compositionality. And technology use for technologies is intelligent control, energy saving, cyber physical system, cyber production system, visual technology, Internet of Things, interface, cloud computing, cloud manufacturing, or additive manufacturing. smart production part on material, data analysis, information and technology-based production management. And the enabling factors, low innovation, education, training, sharing system. So if we talk about manufacturing, so we can see this characteristic, technology, and the enabling factors. So next slide, please. This figure show you that way of the future of smart manufacturing system not only manufacturing itself, but also we have to extend to the supply chains, yeah, to the supplier and the delivery, and all are smart. Yeah. All are connected by information and communication technology. So all we cannot do alone, so we have to go on the system smart. The next please. This is the we very often find, we can very often find 4.0 industrialization. So there is a CPS, yeah, cyber and IoT, and is an integration of computation with physical process, so to integrate, to enhance process control and create synergy between the entity of the physical and cyberspace. And cyberspace is managed by company level. And this is with the help of IoT. IoT is an infrastructure with automation and control among machines in physical space. So we can collect the data and process it and design and then communicate the decision in the IoT, and all are supported by internet. So please. So this also gives an manufacturing. It can be seen that MES is execution systems is in the middle. It can manufacturing execution system for corporate management and shop floor. Okay. And is about operation. So all the company produce customer product as customer can be the producing step. So the company side put information on all types of sales that can be produced. You have a different type of sales. The customer website and choose one of all standard types. The type is then modified. Modification could be the size, the handling materials, and information about of space that next please. Next slide please. The software on the software is able to determine all the processing, and treatment for the owner, including manufacturing costs. The company sends back the design and all the information to the customer, including the price of the new design. The customer asks to send to us and to install them at the place of the address, the company of code for that tool. If option is confirmed, the machine code, production and outsourcing plan per day and price will be generated.
Sorry to
Once the
interrupt.
systems are ready for production, it's loaded onto the system. And all produced or other outsourced are automatically delivered to the customer line, and the customer will receive the order the stage time.
Hakim, Prof. Hakim.
Operation excellence. Next, please.
Sorry to interrupt. Minutes.
Next slide, please. Operation excellence may be defined as a framework more with the same resource. So integrate operation. The key is streamlining and integrate. Operation excellence enables the company the principle right product, right quantity, right resource, right price, and right customer. The company consists of various systems. Achieve excellence, into one holistic management system is in and it's the same as the characteristic of team and system engineering. So we can see the level in a manufacturing company. So there's level, component management level, production management level, and shop floor level. And there are three functions: production, personnel, and quality assurance. So integrate this part. Price, resource planning, production planning and scheduling, and manufacturing access system and automation. So we have to integrate this, and we can define two integration. Next, please. First one is vertical. This vertical integration ensures all information required is supplied to the all level management, so all the information supplied to this level. Horizontal ensure that all functions so production, personnel, and quality can work. Vertical and horizontal one of integration in the level and function. This also show the importance of integration. Customization starts in the cloud. This is where the customer can design and configure their own product fitting their needs. During the processing, the company or the external part, the company have a defined interface to its supplier so that the order to supply process automatically. And kind of integration. Next, please. Next slide, please. This is another kind of integration. This integration very often in discussing the Industry 4.0. There are three kinds of integration. First one, horizontal integration, is built among the companies to form an efficient. Vertical integration is built among subsystems of company, production, manufacturing, and traffic, to form a self-organized system that can dynamically to adapt different customer product types. So horizontal is among related company, and vertical integration is in the company. And the third one is an engineering integration. It's built in the activity chain from customer requirement, that and process design, product in planning, upload activities, and maintenance, service, and recycle. Next, please. Maybe we can skip this. Now, this is only to show how integration is and what is the subsystem in there. So, manufacturing execution service system is the system for function from work order to finished product with optimization of overall manufacturing management. And manufacturing execution system various shop floor activities based on production schedule and shop floor situation. Means that manufacturing execution system in operation excellence, 3. First one, transparency, integration, the business process, and then responsiveness, relation by innovation and technology, and cost efficiency. Again, I'd like to and that the keyword is integration. Okay, next please. So this is the last part of my presentation about system engineering. We can see that what we have discussed, we talked about massification, smart manufacturing, and we can see the importance of it. And we start by the definition of SE, that industrial engineering is concerned with blah, 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 already known of. But what I'd like to do here is, in this definition, there is ability, there are ability, design, improvement, and installation of specify, parameter, and evaluate. And the definition only about the knowledge required, mathematics, physical, and social sciences, and the principles and methods of doing analysis and design. The next, please. And the definition also of object. And the object is, next please. And the object is actually the industrial and system engineering system, integrated systems of people, information, equipment, and also talk about the output. It is not, but we know that the output is high value added product or services with quantity, with high quality, on time delivery and low cost. So we have a classification from the definition, and we can throughout this by this picture of knowledge and skill, mathematical, physical, social science, and ability. This one, like this. And the ability, design, improve, install, specify, predict, evaluate, and the object is integrated system material information, equipment, and the object there's output, and to have the ability to specify, evaluate the output from such the systems. So this definition tell us. Next. Please, next slide, please. So, main concept of investments and system engineering is not with object, but is the approach. That is, and we have already known also that system is an integrated set of interoperable elements, each with explicitly defined and bounded capabilities, working synergistically to perform value processing to enable a user to satisfy oriented operational needs in a prescribed operating environment with a defined outcome and probability of success. So the system approach is how to solve a problem holistically, not related. It should be integrated scenario. And we will find that each student how to understand the implement the approach, the system approach is very difficult. Completely need a model or platform to do the process. So the learning platform to understand the system. So the learning model or the learning platform is the manufacturing system. Why manufacturing is chosen? The reason of choosing the manufacturing system as a learning are all subsystems of a manufacturing system could easily be recognized. A manufacturing system is easy to be found in life. A manufacturing system comprehensible. And the last is manufacturing significantly contribute to the national economy. It should be noted that you don't have to work for a manufacturing company as the manufacturing system a learning model. Grade could work for any industry, any system, or any field as they could take advantages of the system and they could analogize the chosen system. They work to the manufacturing system as analogy for the system. Next. Based on this approach, we understand that we have to change the definition. We don't have to change the approach in system engineering, but we should find the context of manufacturing system adopted as the platform. We have to change to redefine the manufacturing system. We have to shift, we have to change manufacturing that produce and
Prof. Hakim?
to smart manufacturing that produce customized.
Prof. Hakim?
If we
Prof. Hakim?
teach production system or production planning and control, many examples based on mass production. So right now we have to based on mass customization and smart manufacturing.
Prof. Hakim?
So can go to the next slide. Please, one slide. This is body of knowledge of industrial and system engineering. And the next slide, please. This is important. As the industrial and system engineering know deals with the smart with mass customization, the following are also be included in it. This one is innovation. Innovation is very to be included in PSE curriculum, but it's not in general. In product, service, and process. Innovation is defined as new economic significance primarily, and we can see that product service innovation is new or better product services being used and sold. And process innovation is new ways of producing foods, and this can be political or organizational process innovation.
Prof. Hakim?
Advanced production and smart technology also should be adopted, including intelligent, big data, Internet of Things, and cloud. And
Prof. Hakim?
this is the last slide. Next, please.
I read the time, Prof. Hakim.
Next slide, please. The current market is to obtain economies of scope that enable companies customize products with high quality and low price. Companies should change the paradigm from mass production to mass customization. Excellently operating the smart manufacturing must to be successful in practicing the mass customization strategy. And the strategy of mass customization about change to the higher education of the industrial and system engineering in the implementation of learning platform. Thank you very much.
Thank you. Okay, now is we have time for asking. Yeah, for asking a question and Prof. Hakim will answer. So use the.
I'm sorry, I cannot. I cannot. You hear? Okay.
Yeah. Do you hear? Do you hear me, Prof. Hakim? Hear me?
I cannot. Yeah.
Okay. Hang on. Do you hear me now, Prof. Hakim? No?
I'm
Oh,
sorry.
okay. How about my voice, Prof. Hakim? Yeah, I can hear you clearly.
I'm sorry.
Okay.
Prof. Yuri, I couldn't get the message.
Here, you can hear now. Organizer, can you help Prof. Hakim to hear me? The organizer. Okay. How about now?
I'm really sorry. I couldn't
Here.
catch the
No voice.
Suruh keluar masuk aja.
Bagaimana baiknya? Organizer, can you help Prof. Hakim to hear?
Okay. For the moderator, apologize for the technical trouble.
I have problem.
We tried reaching out Prof. Halim, but it turns out that
Really sorry.
there we cannot intervene. So unfortunately, we will cut this session and we'll move on. And we'll move on to our next
Okay.
agenda, which is the photo session. Thank you so much, Mr.
Thank you.
And Prof. Yuri and Prof. Hakim for your insightful session. We may bring a great benefit to all the participants that have participated. Okay, so now we're going to promote participant as panelists so that they can turn on their camera, and we'll be holding our virtual photo session.
Okay. Prof, now? No sound? Okay, right.
Bim, gimana Bim? Munculkan gambar Bim. Gambar. Saya nggak muncul. Ambil. Balas, kayak sakti ya.
Okay, ladies and gentlemen, before we end wonderful session, let's join together for our virtual for this once in a lifetime moment. Okay, right. So it looks like that the committee has promoted all of to become panelists so that you all can turn on your camera and prepare your best smile. Okay. We'll snap in 3, 2, 1. Cheese. Again, 2, 1. Cheese. All right, everybody. I think this photo session has marked the end of the session. You are now allowed to leave this webinar. For participants who will give presentation is expected to join immediately via the link that was sent to the WhatsApp group. Just to remind you guys, the names of the presenters in A and B can be seen in the following screen. Okay. Finally, we would like to thank you so much for your participation. And me, Dafa, as the MC for today's session, would like to excuse myself. Thank you for your time and see you at the next event.
Terima kasih, Prof. Hakim. Thank you very much.